päästiin. Tervetuloa Kokkolan Meriklusterin kolmanteen työpajaan, joka on nimetty satamaturvallisuudeksi ja tämän väyläturvallisuuden monitorointi teemalla. Meidän ohjelma on sillä tavalla, että mä käytän tässä nyt lyhyen alustuspuheenvuoron. Ja sitten meillä on Nils Waltré, joka on tuttu heille, jotka oli meidän avajaisseminaarissa, niin syventämässä ja kohdentamassa hänen tietämystään tähän Kokkolan alueelle. Ja sitä kautta todellakin mietitään ne business edellä silmälasit ja aluekehittämisen näkökulmasta. Aihe on rankka ja jokainen tietää, mikä on globaalisti tilanne, mutta että tässä niin sanotusti valmistaudutaan tulevaan. Ja sitten tosiaan niin nämä aikataulut ei sillä tavalla ole kiveen hakattu, että sitten kun Nilsi on esittänyt omansa, niin sitten mennään siitä tuohon kysymys- ja vastausosioon eikä oikeastaan takarajakaan, että itsekin on täällä niin pitkäänkä porukkaa riittää linjoilla, eli näin. Ja sitten tämä jossain vaiheessa tämä tallenne pistetään YouTubeen, eli se on myöhemmin sitten kaikkien käytettävissä ja jaettavissa. Mutta tosiaan pari sanaa tähän alkuun, eli mistä tullaan, niin Kokkolan yliopistokeskus Sydänyksestä tulee tämä esitys, joka on 3 yliopiston yhteenliittymä Jyväskylä, Oulu ja Vaasa. Ja itse työskentelen Jyväskylän alaisuudessa kauppatieteissä. Ja mun mielestä tuossa on hienosti tässä meidän one-pagerissä kirjoitettu, että me ratkaistaan globaaleja haasteita alueellisesta näkökulmasta, muun muassa erilaisten hankkeiden avulla. Ja me tuotetaan arvonlisää tälle alueelle 20 miljoonaa ja tuotetaan myös kandidaatteja, maistereita, tohtoreita 5 tieteenalalta. Informaatioteknologia, kasvatustieteet, kauppatieteet, sosiaalitieteet ja soveltava kemia, mikä liittyy aika paljon tähän energiatransitioon, joka nyt on menossa. Meillä on jatkuvasti kirjoilla tuhansia opiskelijoita ympäri Suomea ja myös Suomen ulkopuolella. Ja siltä pohjalta sitten Kokkolan Meriklusterin hanke ponnistaa, ja tosiaan 1,5-vuotinen hanke menossa meillä, jossa 3 työntekijää 70%, 30%. Ja pistin tuohon varmuuden vuoksi koko vartalokuvat, että emme ole botteja, olemme oikeita ihmisiä, jotka täällä takana touhuavat. Ja käydään semmoisissa tilaisuuksissa, mitkä antaa lisäarvoa sitten tälle meidän sisällölle tähän hankkeeseen. Ja tosiaankin niin Meriklusterin business on iso bisnestä, puhutaan monen 10 miljardin bisneksestä ja työllistää kymmeniä tuhansia ihmisiä. Mutta tosiaankin nämä lukemat tarkoittaa vain näiden pallojen alueella olevaa liikevaihtoa ja työllistämistä. Ja sen takia meillä on tämä Meriklusterihanke, jotta me saadaan jossakin vaiheessa sitten integroitua tai fuusioitua tämä koko Suomen rannikko niin saman sateenvarjon alle. Että sitten kun puhutaan Meriklusterista, niin se todellakin on sitten kaikki, jotka siihen kuuluu. Ja meri saattaa hieman hämätä, koska kun näitä pallukoita täällä sisämaassa, niin alihankintaverkosto siis kattaa koko maan ja Meriklusteri tuo sitä hyvää koko maan talouteen, aluetalouksiin niin sanotusti. Ja me ollaan alueelta ponnistava, koordinoiva ja skaalautuva valtakunnallinen toimija. En uskaltanut panna tuohon vielä kansainvälinen, mutta ei sekään enää kaukana, kun mietitään, kuka meillä on tänään täällä puhumassa. Ja sitten tässä jo tutuksi tullut kuva, eli ollaan hankkimassa yrityksiä tähän klusteriin, ja nämä logot edustaa yrityksiä, joiden kanssa on käynyt neuvotteluja, jotka haluavat edistää tätä meidän hanketta, ja päämääränä se, että meistä tulee sitten yhteinen entiteetti, joka toimii sitten näiden yritysten hyväksi tässä kentässä. Ja sitten itse tästä Meriklusterin kehitysohjelmasta, niin meidän tavoitteena on liiketoiminnan, alustatalouden ja turvallisuuden promoaminen. Ja siitä on nyt 2 kuukauden aikana jo lähtenyt tämmöisiä spin-offeja, jotka tähtää investointeihin. Eli mahdollisesti meillä on näköpiirissä muutaman vuoden sisällä alusinvestointi, joka tuo hyvinvointia veneteollisuuteen tänne, halli-investointi, joka liittyy dualiuskonseptiin, ja sitten pohdiskellaan, millä alustalla me toimitaan, ja sitten tämän päivän teema on tämä aluehomma ja se tarkoittaa siis alueen turvaamista niin, että täällä business pyörii. Ja nämä kaikki on dual-use-konseptilla ajateltu, koska nykypäivänä näyttää siltä, että se rahoitusinstrumentti menee aina vaan enemmän sinne, että sitä dual-use perusteella saa näihin aluekehityshankkeisiin ja investointeihin. Ja tavoitteena on, että meillä on tämmöinen Maritime Cluster West vuonna 2027, joka tosiaankin on semmoinen avustava ja koordinoiva elin. But today's workshop is workshop 3, and we are diving into the port security and fairway monitoring in dual-use concept. And we have Nils Waltré from Norway and Sweden here. And Nils will give us the overview of situational awareness in Port of Kokkola case and how to protect the maritime infra together with underwater surveillance. Osaamma på finska här. So, please welcome Nils, and stage is yours.
Thank you. A good presentation, and I have the overview from when visited Kokkola a couple of months ago. So then I get presented what has been happened since. And I will go through, as pointed out, the port safety and fairway monitoring. And my idea is that I will give first an overall presentation of Kongsberg. And then after that, I will give the systems and sensors that are able to help in this matter of making a higher security awareness, and then also see down to what can actually be done in the area of Kokkola as a suggestion of sensors and overall situation awareness. So a little bit my background quickly is that I'm a submarine officer and master mariner. And now that I worked on scientific vessels and whatnot, then it was natural to land on Kongsberg, which is very oceanographic company, and also DP vessels that we're working on. Currently working for CTEX in the European focus for senior sales manager for the CTEX. And we'll get to that. So Kongsberg Group, we have satellites, and we have all the way down to deep sea for survey and underwater communication to 11,000 meters. So in general, we are doing the maritime area, and but focus all over the place. About 15,000 employees and growing. 40 countries, and mainly we are in Europe, Northern America, and Australia, and a little bit in these regions. We have 50 billion NOKs in revenues and 4 business areas, which is the maritime, and that is the Kongsberg that you know in this area for waterjet, for instance. Defense aerospace, digital, and discovery is the 4 major part of it. And discovery is the one that I'm part of. Just to go through a little bit, but maritime, they do everything that is for merchant fleet. And in the local, in your area, is the waterjet production. The defense part that is of interest today is the NOR control. So you have VTS stations, and you have surveillance and protection, monitoring, just the awareness of the situation. And otherwise, it's just how to safeguard and see how it can be done in certain offshore installations. And then also for the test bed at the moment, you're saying that we put everything together and you say, this is actually how it works. And My area here is for ocean technologies and this scientific purpose with ADCPs, current profiling, multi-beam for 3D scanning and all the way down and communications, underwater communication. Marine life technology is the old Simrad, which is doing fisheries worldwide, so big fishery sonars, uncrewed platforms. So both we have the autonomous underwater vessel driving by itself and make its own decisions, and this USV, but more of the focus of system towards USVs. And not just our own USVs. CTEX is the one that is doing everything to support all the sensors to support. So we have DP reference systems, which is in the laser and radar and see what's your relative position towards something. And gyro compass, which is the MRU and MDC. So the production is made in Trondheim. GNS positioning with anti-spoofing and so on, see where you actually are towards with the GPS. Active heat compensation, just a motion stabilization of cranes. AIS, we have drone detection, that will be of interest. Mobile broadband radio, home network to make communication, space solutions, situational awareness, and passive radar detection, which can be placed both on satellites and also placed by a station on land, and special projects. This is a good picture to show that everything comes together. So if you have the operator in the center, you will have a decision support to see what should I do when, and get an alarm and whatnot. And then you have monitoring systems for AI machine learning and so on. Then you have the systems that carry sensors, basically. So AOV, USV, stationary at the seabed, and you have also subsea surveillance. So it depends on, this is the system, and then you have the sensors for drone detection, AIS, radars, and whatnot. And above in the fourth dimension is the satellite service. So what is not to forget in this context today is reaction assets and also external system that already exist that can be put in this whole system. So it's not a solitude system, it's more that it goes together in existing systems as well. So reaction assets is a big part of this decision. But we have been focusing on protecting maritime infrastructure because it's of highly interest to see. First, it does exist a lot. Now the focus is in Norway for obvious reasons there, because of energy and pipings. But what we see, the focus has been growing quite a lot for sea, protecting the infrastructure at sea. It's all the things that has happened, and this is not just the Nord Stream, it's on and on and on going on. And this occurs with anchors in outside ports and harbors because of weather and because of other means. But in the Baltic Sea, this is a new thing that has arisen. It's not normal operation that is so many cables are being hit. So something needs to be done for this. And we call it CMI. But to protect the pipelines and basically everything that is in water, but also harbors for because it is part of the merchant fleet for logistic transport and energy supply. So not to forget that one part of it as well. The threats we can see. Okay, weather and seabed, this information that's changing due to time, due to flood, due to weather. something, of course, trawling can happen, but that you can see that make construction for trawling. These things happen, and you can get the engine could be stopped at some point, and you could be drifting. But deliberately harm, this is the one to see how can we first see that it has happened, but also see how can we prevent this to happen. And there are several ways to do this, both in machine learning systems or actually overview with sensors. The trick here is that put everything together and make a full picture of the harm that could be done to the infrastructure. So sensors is from underwater, and see how is the cavitation doing, how is what vessel is coming and going that is not visible with radar or AIS, for instance. Change detection infrastructure, see you make a normal picture of the seabed, and then you will see has something changed in the meantime. Understand and interpret data is basically this, you make a good decision as fast as possible and say, can we make something out of the cavitation of the propeller, for instance? Is something happen here? And historic vessel data, has this particular vessel run over the cables and it's going out from port now? Let's have that highlighted, that vessel. And basically see for the satellite data and down to hydrophones. So everything will be connected. What has been done for surveillance is vessel traffic management and services, so VTS station, and we have been done that for 45 years, but it can be extended to making from AIS and radar stations to make the sensors and see where if they are to shut off the AIS, then we're still able to identify what vessel is coming. And that's also usually a sign when you switch off the AIS that something is going south. But it's basically making together with infrastructure where it is and see if this is of danger or not in real time. And yeah, sensor agnostics and all of that. So it's just it's done together with the coastal administration, coast guards, and those type of entities. One picture that how it looks is that you build layers on top of the picture and see what you want to see. Is it for traffic? Is it for see the pipelines where they come together with the traffic? And also put certain areas of where you should have a look extra if some vessel is entering a certain area. If it deviates from the course, is also. And another layer that is also interesting is that in the Coast Guard perspective, that you can have also for oil spills and a prediction of where the oil will be going. So that is also one of the layers to say how will the oil spill be in 12 hours and where should we direct our fleet, and you have a general overview with satellite pictures as well. So the satellite, yes, very big areas. We have a couple of satellites with the sensors. So with this radar, weather radar, AIS, AIS Plus, and all of those constellations. But the interesting part is NRD, this navigation radar detection. So every radar has their own identity. So you can connect that together with the AIS and say this is the radar that's usually connected to the AIS, because time and how it spins and magnetron and so on. So it gives a fingerprint of the vessel. And that can be detected from satellites and it can be detected from land, but it sure gives down to how many containers is on board and what's going on the vessel. And also down to, just to say, from satellite down to AUVs patrolling the oceans. And in those you can put every type of sensor. So you can have oil sniffers, but usually it's for making a 3D picture of the seabed. So you have multibeams for looking down. You have HISAS for synthetic aperture sonar. It's basically for looking to the side, and you get a SWOT of up to 1,000 meters in this 3 centimeter XYZ point cloud. Sub-bottom profile to see the cables underneath the seabed, and you can also follow the cables with special sensors. So that is just an effective way to patrol and not to have to interact with traffic. And this one can be up to more than 2 weeks under surface, so it covers a long time. Example, you do a survey a week from Scotland to Norway with preparations. Okay, the travel doesn't take 7 days, but you have to prepare and make an altitude. And above the cable, it will be also a laser for a millimeter precision. And if something would happen and you see something is there that shouldn't be there, it goes around and take pictures from different angles coming up and report that something is going on there and send those pictures for the operation center. So at the 80 square kilometers and depends on how much things is of interest that needs to go around and turn around. So if you but this case is quite normal. Change detection, just to see that you have this one 2013 and this one 16, and then you say something has been put there in between those times. And it's a very quick way to just see what to focus on in this area. Interest for the cable operators is if it has been changed, the cables, if they cross each other and so on, for how much amount of power that can be transported between the cables. This is a sonar being dipped in the water, and you also see the Hugin that is can be placed on any type of or can be placed on normal vessels with a sled. This sonar here gives a view of what's going on underwater. So it's active ping that produce sonar and sound in the water, and it tracks back. So you could say a radar underwater, but with a twist. So this sense setup is 500 meters, but you can identify and see what the speed and course is doing and the depth. So an active form of seeing the form that is in the water, and doing that together with hydrophones hydrophones or microphones in water. And this one is for making example that you can hear an anchor being dropped from a vessel. So you know where the position of the vessel is, and you can also hear what's going on for the vessel, and cavitation of the propeller gives an identification of the vessel as well. But this noise level can raise the awareness to this maritime operations center and say, hey, something is going on here. You should have a look at this vessel, and also be able to call up that vessel and say, you have dropping an anchor, just so you know, and send reaction assets to also stop the what's going on. So it's one way to actually know that this is ongoing, and you're able to stop operations. Otherwise, for positioning noise in the water, you can have a lot of passive hydrophones. And this case they've been tested to 400 meters, and it gives a really good picture. And why to come down a little bit in the water is that you have layers of salt that you maybe want to come below because of refractions in the water. So this is also an effective way. So it can be towed behind a vessel, a hugin, or it of course will be placed on the seabed if needed. We have been talking with Tykoflex, and Timo, maybe you know about it because of the cable reparations. And this company repair cables that is on the seabed. So it picks it up and just in a day it makes the repair and can be put back. And in the meantime, it can also be splicing out a communication cable to underwater cage with our sensors. So we're able to make a communication in the existing cable with the sensors, and the one that is of interest for knowing what's going on is a hydrophone. So for passive detection, but you can also have communication up to an AUV, and with that also you get an extra positioning indication for the AUV saying this is where you are, and in that sense can also be sent to the vessel. So if a GPS is being denied out of jamming and spoofing, you're still able to get a position towards this seabed cage with underwater communication. And then in this dual use context, you can have a scientific sensors with ADCPs and water column biological data, and sonar can be put there and so on. So there are a lot of possibilities to put sensors, depends on your need in this area. Another take that we were just last week, a big event in Kokkolan North, but for having drone and everything that moves around surveillance in the air. So you have 10 kilos of solid state radar that gives out pulses all the time and not rotating. That gives a good indication of position, everything that moves. Together with camera for making a picture. So this drone radar gives XYZ of the system that is moving, and it directs the camera towards that position. And it's also for machine learning to say how this is moving indicates what thing that is moving. So it gives also a machine learning of, is this a human, is this bird, or what's going on. The system that is not total more, but we have also communication, internal phase shifting communication devices for this MBR communication. So you can stand and you have your own mesh network of situational awareness with cameras and drone radars. And just to say, this radar can classify also what's going on in the area. So it's not just movement and you get the dot, you get also how is the dot moving. So you have a helicopter gives certain movement, but if you have a squad of quadcopters and one of them has a heavier load, you can see that specific one is moving with a little bit higher frequency of the rotors, propellers. You can see that is the one we should focus on. And also crow, and you can see a human how that is moving. It gives just an identification for what is the movement, and everything that moves gives a certain classification. Here is an example of what is being set up. Yeah, so you have the cameras, you can move around, you can zoom in, you give also position where it is, you get if it's a car, a helicopter, or what kind of system to classify if it's friend or foe. So it gives an overview of the situation basically there. And you have something that's moving but it's not classified and clutter, and so which could also be of interest in this area. We set up everything for this in Horten, just to see test the system if it works, and it works good. On this Maritime Operations Center, and putting the awareness and just to demonstrate, this is of focus, and if discussions are to take place, then this is a good place to come and have a discussion about this. But everything joined together. Looks like this. You have the satellite pictures and what of interest, and just gives this massive overview of VTS station plus. But now we are focusing on Kokkolan. So taking all these figures and just say what is of interest and how can a good situational awareness take place in Kokkolan, and see just the nature and terrain is that there are 3 possible ways into Kokkolan, and then you have the outer sea, which from can be patrolled by USVs and AUVs or vessels to patrol in the area for intervention if something would take place. And the next line of protection is coastal radar, and that you have AIS and this radar and identification systems could be placed on those one. Fiber optic sensing, well, it's a good way to see that the cable, if the cable is being cut, you can see when you get a timestamp for when it has happened. it senses energy being put into the cable. So together with fiber optic sensing, you're able to see where the energy is being take place. And together with the hydrophones, you get a really crisp picture of what's going on. So those two together are working really good for underwater surveillance. Subsea stations, well, depends on what your needs is, but the simplest thing is a hydrophone. And then you can scale up and see if it's anything really silent. We want to know if it's moving towards in this direction or not. Or scientific purpose, and see if oxygen levels and so on. So you have scientific sensors into it. Next line of surveillance would be the drone radar. So drone radar will take about 3 kilometers, and I would say it's about 4 kilometers between those and drone radar. And with a PT set camera, you get a really nice crisp image. And as you see down to bird scale, you're able to see if a canoe is passing in, you will able to see it. And as calm waters, swimmers and so on. So it's a crisp image of movement, basically. Satellite data, well, okay, it's nice to know, but you'll in this area, maybe it's more the local sensors is of more of interest. If you go down to the actual area, harbor area, we have a diver detection sonars for this specific purpose to have, if someone is diving in the area, it also gives sonar detection together with hydrophones. And also in the area for drone detection is to see if there's any airborne drones for protecting the harbor itself. And down to the Maritime Operations Center, just to get an overview of the area and communication with VHF, and just to see from the terrain and for what's possible. This could be a picture to get the surveillance for Kokkolan, in my perspective. So that Seppo, that would be basically the end of the line for presenting, and in this dual use context.
Yes, thank you very much, Nils. And I think it's time for a discussion now. So I turn off the recording.